Atmospheric rivers have surged into the spotlight, a term that flew mostly under the radar until recently, despite being coined 3 decades ago as a more accessible replacement for tropospheric rivers. The name atmospheric river debuted in a 1993 LA Times article showcasing work from MIT and NASA that later appeared in a 1994 research paper. Introduced, then forgotten, the term resurfaced in 2011 when scientists warned of its potential threat to California. Earthquakes might not be the only big one. An arc storm, initially projected as a 1 in 1,000 year atmospheric river superstorm, is now expected to occur more frequently due to climate change as rising global temperatures increase the total atmospheric water vapor. The colloquial term Pineapple Express denotes an atmospheric river originating in Hawaii as experienced by the West Coast. This term emerged in the 1960s, roughly coinciding with the onset of the collapse of Hawaii's pineapple industry. Today, the industry primarily meets local demand. Atmospheric rivers transport concentrated water vapor, posed as analogous to terrestrial rivers. Interactions with mountains or local atmospheric dynamics cause the transported moisture to cool and condense, resulting in intense rain or snow. Critical for the water supply, atmospheric rivers contribute up to 50% of the West Coast's annual precipitation, ending over a third of California's major droughts. California receives an average of 44 such storms annually, with 6 strong winds providing the majority of the total precipitation. Atmospheric rivers often stretch over 2,000 kilometers and can measure 400 to 600 kilometers in width and 3 kilometers in depth. While measuring terrestrial rivers is imprecise, the Nile at 6,700 kilometers holds the title for the longest, followed by the Amazon at 6,400. The Amazon River's discharge rate of 209,000 cubic meters per second is 5 times higher than the second-place Congo River. The flow rate of water vapor through an average atmospheric river is more than double that of the Amazon. The intense rainfall from atmospheric rivers often leads to significant flooding, landslides, and other disasters. Consecutive storms cause 3 to 4 times more economic damage than individual storms. The Great Flood of 1862 marked the end to a 20-year drought in California, brought about by 43 days of continuous storms caused by a series of atmospheric rivers. The Central Valley transformed into an inland sea, and Governor Leland Stanford took a rowboat to his inauguration. With Sacramento submerged under 10 feet of water, the state capital was temporarily moved to San Francisco. This historic storm and subsequent flood, unmatched in magnitude, serves as a benchmark for California's vulnerability to extreme weather and forms the basis for the arc storm what-if scenario. A few weeks ago, a powerful atmospheric river chased a smaller one and drenched Southern California with up to 14 inches of rain over 5 days, resulting in evacuations, hundreds of mudslides, and widespread flooding. Projected damage costs from this storm reaching $11 billion. Currently in a strong El Niño, warmer sea surface temperatures are linked to heightened atmospheric river activity. There's a 79% chance of transitioning from El Niño between April and June 2024, followed by a 55% chance of La Niña development between June and August. Water vapor, like in atmospheric rivers, is invisible. When the air reaches 100% relative humidity, it is fully saturated and condensation occurs, transforming the water vapor into visible water droplets and ice crystals, giving rise to the formation of a cloud. Low-level clouds are composed entirely of water droplets. High-level clouds contain ice crystals. And mid-level clouds are primarily composed of water droplets but may contain ice crystals at low temperatures. Nimbostratus and cumulonimbus are the primary precipitating clouds. Cumulonimbus is the thunderstorm cloud, featuring a powerful vertical updraft extending into higher altitudes. Beyond the traditional definition, other cloud considerations arise. You may have walked through a cloud before, as fog is a cloud that formed on the ground surface. Contrails are man-made clouds that form behind aircraft. Contrails, or condensation trails, form in 2 distinct ways. Exhaust trails form at cruise altitude in the upper troposphere, when hot and humid engine exhaust mixes with cold air. In high enough relative humidity, these can become long-lived and spread, potentially evolving into cirrus clouds. Aerodynamic trails form at lower altitudes, typically near takeoff or landing when the aircraft is moving at lower speeds. In very high relative humidity, a tip vortex from the wing, or a propeller, induces a temperature drop that fully saturates the air, resulting in short-lived trails. While stealth aircraft capabilities minimize radar and infrared detectability, they can still become conspicuous to the naked eye, as they are not immune to forming contrails. In contrast to their limited use for stealth aircraft, radar and infrared play crucial roles in weather forecasting and monitoring potential hazards posed by atmospheric rivers and other storms.